everyone. This study focuses on quality assurance in the automotive manufacturing industry. Quality assurance or QA is a systematic approach used to ensure that products consistently meet quality standards, customer expectations, and regulatory requirements. In the automotive industry, quality assurance is especially important because vehicle defects can directly affect the safety of driver, passenger, and other road users. Effective quality assurance helps manufacturers prevent defects, improve customer satisfaction, maintain regulatory compliance, and protect their corporate reputation. Therefore, automotive manufacturers must implement strong quality management systems to ensure that safety-related components function correctly before vehicles are released to customers. In November 2024, the Road Transport Department or JPJ announced a recall involving 2,518 units of 2024 selected car. Affected vehicles were found to have headlights that did not comply with the required height and alignment specifications. Since headlight an important safety component, improper alignment may reduce visibility and create safety risks for both driver and other road users. Because of this study was conducted to investigate the possible quality assurance weaknesses that may have contributed to the recall. To achieve this objective, the study applied the Six Sigma DMAIC methodology together with the Fishbone Diagram to analyze the issue and propose suitable improvement strategies.
For literature review, our literature review identified two major pillars. The first is key term 1, quality assurance or QA. As we analyzed the literature, we found that QA actually as the absolute universal foundation across every single piece of research we review. It's focused heavily on maintaining systematic quality standard rather than just checking for error at the very end of the product line. As shown on the slide, this term is universal support by all 10 authors in our matrix, including Deming, Juran, Auckland, and Fonseca and Dominguez. Moving to key term, we look at the IATF, which represents the International Automotive Task Force Standard. This term focuses on specialized quality management systems specifically tailored for the automotive environment. The literature has to explore how global industry standards align with everyday organizational process to improve reliability. This specialized is the support by three authors like in three key terms focus on SPS and processing monitoring. Statistical process control is highly emphasized in the literature as a way to utilize data-driven tools to stabilize product line and minimize a process variation. Instead of organization use data to make informed decisions. This term has a substantial backing in our research metric and is a support by authors such as Deming, Silva, Antoni, Fonseca, Dominguez, and Nunes Lopez. Finally, key term 4 is a defect prevention. This core focus here is taking proactive measure to eliminate error before they ever reach the final product phase. This literature emphasizes a critical culture shift with the company moving away from a reactive inspection mindset and moving through proactive mitigation. Just like generic QA, this term is so fundamental that it's supposed by all 10 authors in our study, including Juran, Talapatra and Udin, Fonseca, Dominguez, and Nunes Lopez. Our literature review demonstrates the modern quality assurance released on combining these data-driven monitoring tools and standardized framework to successfully prevent defects before
they study. We adopt a qualitative secondary research approach. This method was chosen because the issue being investigated a real recall case that has already been publicly reported by JPJ and selected company. The data used in this study were collected from official recall announcement, JPJ statement, automotive news, report, and academic literature related to quality assurance and quality management system. To analyze the issue systematically, we apply the Six Sigma DMAIC methodology, which consists of 5 P's: define, measure, analyze, improve, and control. DMAIC was selected because it is a structured problem-solving framework that is widely used in manufacturing industry to identify quality problem, determine possible cause, implement improvement, and prevent similar issue from recurring in the future. The main problem identified was the recall of 251,800 units of the 2024 selected company AZA due to headlight alignment and heat specification that did not comply with JPJ requirement. Next, in the measure phase, we evaluate the significance of the issue. Although the effect vehicle represent only a portion of production volume, the problem is considered as serious because it involves a safety critical component that may affect driver visibility and road safety. For the analysis phase, we use a fishbone diagram as our main quality tool. The fishbone diagram helps us identify potential cause of the issue and the 6 category: man, machine, method, material, measurement, and environment. Based on the analysis, the most likely contributing factors were related to inspection procedure, measurement system, equipment calibration, and verification activity. Since Produa did not publicly disclose that exactly root cause, the fishbone diagram was used to identify potential cause from a quality assurance perspective. In the improved phase, several recommendations were proposed, including regular equipment calibration, stronger inspection procedure, and additional employee training. Finally, in the control phase, continuous monitoring, periodic audit, and regular review of quality procedure were recommended to ensure that similar quality issues do not occur again in a future vehicle production.
Based on the DMAIC analysis, several potential quality assurance factors were identified as contributor to the headline non-compliance recall. The recall involved 2518 vehicles, indicating that the quality assurance system was unable to detect the issue before the vehicle reached customer. To investigate the possible causes, a fishbone diagram was used as the main quality tool. 6 categories were analyzed, namely man, machine, method, material, measurement, and environment. Among these categories, machine, method, and measurement were identified as the most significant factor. Machine-related issue may involve inaccuracy in the optical aiming system used to inspect headlight alignment. Method-related factor may be linked to weakness in inspection and verification procedure. Meanwhile, measurement-related factors are considered the most critical because quality assurance decisions depend heavily on accurate inspection data. Therefore, the findings suggest that weakness in measurement, control, and verification activities may have contributed to the recall. The findings of this study are consistent with several quality management theories discussed in the literature review. According to Fonseca and Dominguez, quality should be integrated through the entire production process rather than relying on the final inspection activities. Similarly, Juran emphasized that quality should be achieved through proper planning, quality control, and continuous improvement. Deming also argued that most quality problems originate from the weakness in process rather than individual employee mistakes. This supports the finding of our fishbone diagram analysis, which indicate that the recall was more likely caused by process-related issues such as measurement system, equipment calibration, and inspection procedure. To address this issue, several improvement strategies are recommended. These include implementing regular calibration schedule for inspection equipment, introducing additional verification procedure, strengthening employee training program, and conducting continuous quality monitoring. These improvements can help prevent similar quality issues in future vehicle production and strengthen overall quality assurance performance.
In conclusion, the study examined the quality assurance issue related to the 2024 selected car headlight recall involving 2,518 vehicles. To investigate the issue, the study applied the Six Sigma DMAIC methodology as the main framework and used the fishbone diagram as the primary quality tool. The analysis showed that the issue was likely related to weaknesses in measurement system, inspection activity, equipment calibration, and verification procedure. Although selected company did not publicly disclose the exact technical cause of the recall, the DMAIC framework provide a systematic approach for identifying potential quality assurance gaps and understanding how similar issues may occur in manufacturing environment. Based on the findings, several recommendations were proposed. First, manufacturers should strengthen equipment calibration management to ensure accurate inspection results. Second, the inspection and verification procedures should be improved and by introducing additional checks for safety critical components such as headlight. Third, continuous employee training should be provided to improve awareness of quality standard and regulatory requirements. In addition, continuous quality monitoring and periodic audit should be implemented to identify process deviation at an early stage. Finally, manufacturers should continue to strengthen compliance with automotive quality standards. By implementing this recommendation, company can improve product quality, enhance regulatory compliance, and increase customer confidence and reduce the risk of future product recall. So that's all from Group 21D09. Thank you.